Hello everyone. This is Dr.G.Anita Hebsiba, Department of Chemistry, Dr. S.N.S. Rajalakshmi College of Arts and Science, Coimbatore. In this video, we are going to study about a different novel technique of dyeing called supercritical carbon dioxide dyeing. Textile industry usually uses a lot of water for its wet processing uh, techniques. So starting from resizing to dyeing and then for the finishing process, we require tons and tons of water, and the water which is being used by any dyeing industry or else any textile industry is sent as effluent uh, outside, which again pose threat to the water bodies and also land. So with this view, this thought of there is supercritical carbon dioxide dyeing is uh, evolved so that we could uh, reduce the amount of water which is being used in every textile industry. We very well know that carbon dioxide is a gas and it is readily available, cheap, recyclable, non-toxic and non-flammable too. So it is readily available in the atmosphere. Every plant or tree uh, gives out carbon dioxide. So the amount of carbon dioxide in the atmosphere is enormous. So that enormous carbon dioxide can be utilized for textile wet processing. Above the temperature of 31 degrees Celsius and pressure of 73 atmosphere, carbon dioxide exhibits physical properties which are intermediate between those of a gas and a liquid. So we convert this carbon dioxide into a phase which is between a gas and a liquid. Okay, these conditions are called supercritical conditions and are readily achievable using commercial available equipment. Supercritical carbon dioxide is able to dissolve a range of chemical substances including carbon, organic substrates, catalyst and light gases. So usually we use water as a universal solvent, but here supercritical carbon dioxide is used as a solvent in textile industry. Its main advantage, however, comes from the fact that this solvent can be easily turned into a gas by simply releasing the pressure, leaving no solvent residues and requiring no evaporation or separation. This is one of the added advantage. What are the characteristics of supercritical carbon dioxide? No surface tension in a supercritical fluid, no liquid gas phase boundary. By changing the pressure and temperature of the fluid, it can be tuned to be more liquid or more gas. Okay, when you adjust that pressure and temperature, it can be either converted into a liquid or can be converted into a gas, whichever is needed. Soluble in material in the fluid. Solubility in the supercritical fluid tends to increase with the density of the fluid at constant temperature. So it is used as a very good solvent, which is our need. Density increases with pressure. Solubility tends to increase with pressure. What is the idea of using the supercritical carbon dioxide in dyeing? The textile industry is believed to be one of the biggest consumers of water in conventional textile dyeing. Large amounts of water are used, both in terms of intake of fresh water and disposal of wastewater too. On an average, an estimated 100 to 150 liters of water is needed to process around 1 kg of textile material, with some 28 billion kilos of textiles being dyed annually. We use a lot of textiles for our daily use, and they need to be pre-treated, dyed, and for every 1 kg you need 100 to 150 liters of water for its processing. Water is used as a solvent in many pre-treatment and finishing processes such as washing, scarring, bleaching and dyeing too. Hence the elimination of water being used as a solvent would be a real breakthrough for the textile dyeing industry, and it seems that this has now come to fruition with the launch of the world's first ever industrial dyeing machines that uses supercritical carbon dioxide as a replacement for water. The manufacturer behind the system is the Dutch company that is Daiku Textile Systems BV. This is the futuristic dyeing technology. Dyeing with water causes large amount of water. great expenses, and it requires huge after treatment processes too. So dyeing with supercritical carbon dioxide, no water or less water, capability in low water regions. Green chemistry can be practiced because it doesn't pose any threat of pollution, no after treatment required, recycle of carbon dioxide, utilization of dye in a prop, a more efficient dyeing with maximum safety and low cost. These are the advantages of using dyeing with supercritical carbon dioxide. Actually, when we use the supercritical carbon dioxide, we are able to reduce the water consumption. We will be able to reduce the process of global warming too, because carbon dioxide is one of the gas which contributes for this global warming, and the effects of global warming are well pronounced and we very well know about it. So by using supercritical carbon dioxide as a solvent in dyeing units and in textile industry, we are also contributing for the uh, reduction of the ill effects of global warming. Thank you.